time if you have any questions on this. So session proxy and then CDN, right? The server farm is not scalable enough. Because having more is not enough. Physically, it has to go closer to where the users are to have a true performance, and that's what CDN does. So it started in the late 90s. So you see that these are the, people in this area have seen some issues, but these are the people who have had a vision. No matter what we do, this is not gonna work, and soon, very soon. Let me see. Okay, so very soon it grew a lot, right? I want you to have some names. Remember some names of CDN besides Akamai. So in earlier, just short assignment, I used to have, list 10 different CDNs. So you just do a Google search, Limelight, HS. So there was a big one in China and other countries, starting to have that. And the research papers around the time was that how do they perform, how much performance gain do they bring with and without, things like that. So a lot of research ideas can be just new algorithms, new techniques, and also another type of research would be the measurement, monitoring, performance evaluation, and there's been a lot of studies around the time. It's an overlay network. CDN nodes are not really switches and routers, right? They have a specific purpose of content distribution. One single point of failure, reduces server load, reduces latency, reduces congestion. So, on all measures of major performance parameters, it's better. I mean, some might say, well, it duplicates a lot of data, creating too much footprint. It's a waste of things. But besides that, these days the storage is, let's not get into that argument. But anyway, if you really want to find some issues, you can. But in terms of performance, you're not turning back, right? This is my different trigger, or different trigger, and I'm not used to this much. So if you didn't know about CDN before taking the class, because it's not really user-facing product, it's transparent to end user, but basically all the content providers do use CDN, and of course there has been lots of academic CDNs for better visualization and so on. Definitely you can think of some. I've been using CNN as I tend to use the CNN as a lot of examples for content provider, but rather than that, there are these days bigger content the producers or providers there, like the Meta, Facebook, and Netflix, bigger amount of content. And when they have those issues, they initially started with a CDN, but they find that, well, it's they find themselves relying on the external content distribution network a lot, then eventually they do on their own. That's what you actually see in most of the technology scene, even in AI, right? The AI for all cloud, basically. I mentioned the Samsung or any country's the big countries. I mean, any country's big companies. They don't want their data to be placed on somebody else's in a different country, or maybe the their their contract related information or perhaps the patent related information and so on. So people do things on their own. That's a good thing for you, more job opportunities, right? And also, so cloud, the any translation AI related one is happening, and you might see any technical conferences, bigger scale technical conferences. There are a lot of conferences focused on a smaller area, but also the bigger scale the conferences, and also major companies, they have their own conferences, like Google, they have their own, Amazon have their own, and so on. And then you will see that you can actually, without going there, you can see the YouTube videos, keynote talks, and the what's happening there. The those companies make, not only have their infrastructure on their own, but also hardware, AI hardware. They're trying to they build themselves, like going down, for example, NVIDIA making GPUs, and then they find that all cloud providers, they have to use AI a lot, and then AI relies on GPUs. They rely on NVIDIA, for example. Then they try to do things on their own, right? So you might see that things are kind of all concentrated in three major clouds. That's not the case. That's the point I'm trying to make. So you know how it works. Basically, different types. So I'm going over quickly, kind of waiting for your questions as we go. So the terms origin server, and then client and surrogate servers are for replicas. Those are terms we use for CDN. Proxy server is often, we use the term for the fake server hosted by an ISP. That's, we call it proxy server. Surrogate server is often used in the context of the CDN. So here, request routing and distribution and accounting infrastructure. So the CDN, they have their own infrastructure network. You might see that, the client just need to find what is the closest one and get it. But in order to provide the closest one and do all the building behind it, they have to have these infrastructures: request routing, distribution infrastructure, and accounting infrastructure. This keeps exceeding. So all these infrastructure. The most important thing in terms of technique would be request routing. Distribution has to be there for any ledger content to be distributed to all of the surrogate servers, some of the surrogate servers. So those delivery infrastructure has to be there, and there should be accounting, who is watching which one for how long. Those kind of the accounting info has to be measured, monitored, and reported. So those things are necessary, but the really, if you were to compare different CDNs, it's all about the performance perceived by the users, and that will be about which server is being used for certain set of the client. So for that request routing or redirection, the has to work well. That's the secret, where the secret sauce of the CDN is. That's where the comparative performance can happen. So I mentioned about the best CDN. The slide that I wanted to get to is that here the user has to access content from the nearest content server. Which one is near? That's the key, right? What do you think? What are the which one would be near? Which server would you consider is the nearest one to a client?
Local server.
Local server. Local server means it's within an ISP. It's not a CDN.
Okay.
Right? So local server. That means a server within the same network. That's not that won't be practically the case. But I think surrogate server. So which surrogate server would be the nearest one? So there can be a lot of metrics. Physically, physical location, right? At 10 kilometers away. That can be some parameter, but which one would be the best? Let me go to it. So that's the question. And I want you, that's actually where a lot of papers on CDN is about, how do they define nearest server, and then once they find the nearest server, the redirecting or connecting, matching the nearest server and client it can be done relatively straightforward. How? URL rewriting, and then redirection, right? The DNS redirection. So those things. And also before surrogate servers are being placed, the CDN part of the work is that some of the content will be pushed to surrogate servers in advance. Some of the content will be pulled by some servers. They was pulled by a user or triggered by a user, eventually pulled by other surrogate servers. So the trade-off between push and pull, it's always it's something that CDN has to do. So URL-based request rewriting and DNS redirection, those are the main things. Anycast is a kind of the high-level term to enable this content redirection. Right? So I am assuming you have taken network architecture class, right? So, but if you're rusty, we didn't do this like that last time, right? Yeah. So, DNS stands for what? Domain Name Service. It does the address mapping between IP address and URL, right? There are actually a lot of translation or the address translation in the network. For example, well, if you type on www.cnn.com, my favorite example, the that has to be translated into IP address, and that's done by DNS. IP address later it has to be translated into MAC address in a local network eventually. The or the from your network that address that mapping on there from your computer when you say when you type in www.cnn.com the IP address mapping DNS and then that IP address is likely that is outside of your network. You are not going to be in CNN network. You are either UMKC network or Starbucks network. It's a different network. Then that traffic, any traffic to CNN.com has to go outside of your network. Then you have to send your traffic to a default gateway router within your network, and that is for that you need MAC address, link layer address of your default gateway router, right? That translation is done through another protocol called ARP, right? The address resolution protocol. Anyway, there are multiple the address translation protocols, but DNS is the one that does address translation from URL to IP address. So DNS record has multiple types: A record, NS, CNAME, MX, A for actual IP address translation. But this is a simplified. Okay, so this is a simplified. Maybe I will just do this. Simplified resource record of DNS. There are a few more, but basically it has a name, value, and then time. TTL is not IP TTL; it's an actual time, which is a few minutes or a few minutes in the order of a few minutes. So here, the name, for example, would be domain name, and value would be IP address. In that case, this record type is A. Sometimes the name can be the CNN.com or the UMKC.edu, and then type can be NS. That means that it's the name server name, authoritative name server, right? Type can be MX. That's a mail server. Okay. CNAME means it's a canonical name, meaning that actual name. So www.cnn.com is very likely it's just a nickname because there will be a lot of real servers that has the same nickname, right? So in that case, the one of the actual the name will be given in the value, then the type will be CNAME. So again, www.cnn.com, w1.cnn.com, actual name, and then CNAME. That's a possibility, or w2.cnn.com, right? So this is how it works. The different types of DNS, and so because of the CNAME, you can have the same name, www.cnn.com, nickname, that everybody can remember, but you can have a lot of other names, other a lot of machines, right? Then you also need the w1.cnn.com A record to find out IP addresses. I just don't know, not sure if this is obvious to you or you are rusty on this. So how do you find out the IP address of your the IP address of some URL? Your browser will do it automatically to the DNS, but you can also find it out using tools, right? Like lookup, right? Yeah. So those are command line tools. These days also there is available on the web-based one too. But again, if you want to, you do need that the command line tools for any network related troubleshooting. So this is how DNS name is resolved, in your local host to all of these servers in the DNS architecture layer. Root DNS server, TLD, top level domain name server, .com, .edu, .kr, .cn, things like that. And then from there, it will find out, the local DNS server will find out authoritative name server of some domain. In this case, cs.umass.edu. What's authoritative name server? That's a dns.cs.umass.edu. So this is the one who does have IP address of, say, gaia.cs.umass.edu authoritatively, right? Does it make sense? Yeah, so this is how DNS works. And you can use this DNS, the DNS to this. You want to have a lot of servers for the same nickname, and you play with this DNS to make it working, right? So that's what it does. I showed you a slide earlier. First of all, DNS redirection. That's where if you access some content like picture or video within the CNN.com website, that object URL will be rewritten by CDN companies. It will be under cdn.com/something, right? And then under CDN, that's what did I say? That's a URL rewriting, right? This is not working as I expected. So that's URL rewriting, and DNS redirection is where the authoritative DNS server that by CDN will redirect actual IP address of a surrogate server to closest one to a client. Okay, so that's. Please stop. Let me know if you have any questions. Right. So URL rewriting and DNS redirection. It's just a technique to steer the request to something else, to a different surrogate server. So this is this is what everybody uses. This is not a secret sauce. This is a basic technique that CDN will do. Right? The extra secret sauce is that when local DNS server is trying to find out the CNN.com website content, among the multiple surrogate servers, they do their own measurement, and eventually DNS response will be the one with the closest to this client. From this DNS response, it will make a request of the content or the object, embedded object, to this surrogate server. Okay? So you might think that, this is coming from CNN. That's not the case. The URL is rewritten, DNS is redirected, and then finally, using this response, this client will access the content from this service server, but behind it there are a lot of activities involved. Anycast is just a term to enable this. So the anycast, you know that unicast, one-to-one, multicast, one-to-many, broadcast, one-to-all, and anycast, one-to-any one of them, right? It's a one-to-one, but you are not designating, I want to speak with her or him with a name, just that I want to have this content, but there can be multiple servers, and one of them will be given to a client who make the request. So that's just a meaning of anycast, and it is done at the IP level. Anycast can be at the application layer level, but it can be done at the IP level. That means that it uses DNS redirection, URL rewriting, all those things. So this is a slide that I really wanted to say. Which metric is the most important when choosing a server? And there can be a lot of these things, right? Geographic location, Kansas City, or actual physical distance, probably that's not what you can even mention there. Geographic location, RTT latency, data rate bandwidth, or who has the hardware if there are not many. And then you can also come up with some other metrics. And this is where the CDN operator's secret sauce is. And this is where a lot of papers has been generated relating to CDN. Peer-to-peer system is the final one. Remember, the server farm, proxy the server done by ISP, and then CDN, and finally peer-to-peer system. And when we say peer-to-peer, the not necessarily as a server, the self-volunteering nodes. That's what that's the context is about. However, there has been, again, a lot of research has been done, and there are techniques to enable peer-to-peer system communication really efficiently. We are not getting into much detail, but what it provides is that it enables, suppose there are multiple peers, content distribution, and self-organization, symmetric communication, these are all possible with the peer. Symmetric communication is actually relatively simple. In the socket level programming, you have both server side and client side of the code. That's what it means. And server can be churning. They can go in and out anytime. But still, there can be some structure of the peer-to-peer system to do the content search and mapping would be more efficient. So the first, next slide? Yeah, I have a backup slide. So BitTorrent is the third structured the peer-to-peer system. The earlier version is, Napster, Nutella, they were not structured. So the content going in and out, centralized one is possible, but it has a copyright issue. Decentralized one, performance issue. Structured one is actually the one that is studied a lot. Again, a lot of research papers, and the technique has been used by cloud companies among their servers too. So there are theoretical bound limits how many hops you have to go through to be able to search, not how many hops you have to go through. The maximum number of hops you have to go, you may have to go through to get the content, and it's bounded by basically log and node. So that's there are a lot of studies that's going on. we often say BitTorrent is the one that has a lot of cool techniques like shown over here. I'm not going to necessarily ask in the exam for this class, but I do ask the question, these things in natural architecture class. Oh, I don't think I put this one in your case. So distribute hash table, if you actually search it, there are a lot of things. I meant to actually go through that rather quickly before data management. So if you're interested in the secret sauce part of the CDN, please take a look. I think I have put maybe a couple of papers on that. Questions? Okay. If not, so we still have a few more things on storage before we go to network virtualization and data platform. So that includes data management, storage services, Facebook, storage system. Yeah, those things. So today, data management issues. When you think about the compute-related cloud services, there are so many. Later, you will see big data platforms and so on. But for data storage, you might think that it's just a container, the placeholder for files. But there can be many different type of storage services too, and also there are a lot of requirements on storing data because it's about data. Data science or data. Whenever these days people are more aware of importance of handling the data. So I think it's not that new to you. So first, let's talk about the data management. What kind of issues could be there? For companies' perspective, they might have a lot of requirements. They have to handle data well. Okay. So the purpose could be public image. If you have a data breach incident and be on a news, it's not good, right? So for public image, they have to manage their data well, and then also to detect or thwart any criminal activity, to protect the IP, all those purposes, and also for traceability to quantifiable obligations and requirements, government, state, federal, or that the industry alliance in the field, they may have a requirement, and you might have to show the conformance to the obligations and requirements. So even for that purpose, data has to be managed well. These are the concerns, and then there will be policies based on those the concerns. They might have policies in the organization, how to retain, how to disrupt, how to they disrupt data and also keep their data confidentially, right? We call the first week or the data center tour, Google data center tour video. How do they shred their disks, right? So there can be some policies. You may not just throw a disk in a trash can. So in terms of regulatory data obligations, there are these requirements like HIPAA compliance, and then industry-specific one, the health industry, and maybe financial credit card industry. Different industry has specific requirements, and also different country have a specific requirements. I mentioned that the financial credit card industry, they have a very stringent requirement. And then these are the types. Some data are more valuable. That does require reliability service. Some data is very sensitive. It has to be kept secure. So some data may be both valuable and sensitive, and you have to handle according to the policy. What can you do for valuable data? Again, you need to keep the data reliable. How can you make it reliable? You do replicas. Okay, make a replication is something, and also redundancy can be done through RAID. Okay, not complete replica necessarily. And also disaster protection, not just a replica placed in the same building, but in a different geographic location. So these are the practices that they do to handle valuable data for reliability services. What about sensitive data? You want to provide the security services, and that can include confidentiality, meaning encryption, and access control, do a permission control, and also integrity, immutability. By the way, these are the security services. Okay, I told you multiple times, in a running joke in a company or any technical meeting, you might go, if you don't understand, what about security? You can still ask questions, right? Security, it's not just one thing. There are you have to be ready for the next question. Security is there are different types of security services. So depending on that, you would have to do different. You have to apply different techniques. So confidentiality, integrity, availability, access control, immutability. These are the examples of security services. Do you sense that you could come up with the questions, exam questions, quiz questions from this? Okay, so those are the data management issues. What about storage services? Storage can provide services too, not just the putting data somewhere, and that can be, as we just talked about, replication and security. But also virtualization is a security services too. And thin provisioning is a security services too. Provisioning means that you prepare capacity in advance for the future use. Typically, you might have to do a lot. Thin provisioning by the word, you can imagine that. You can sense that maybe you don't have to do a lot. You don't have to plan too much in terms of future capacity. So that's what it is. We'll go into a little more deeper. And data deduplication is a storage services too. Okay. So again, these are storage services. Storage is not just throwing data somewhere, putting in a folder. That's not it. There are a lot of issues, management issues, as we talked about, and also there can be storage services in terms of virtualization, replication, security, thin provisioning, data replication. So oftentimes for a company like, suppose Facebook, they classify data into not just a valuable and sensitive, but the regular data. So all the people's picture data, video data, users post. In terms of sensitivity or value, it will be all the same, right? So even under the same type of data, you can still classify it into these kind of categories: warm, hot, hot, warm, and cold, right? Um, these like temperature word. Nearline, standard, archive, port line. There can be another classification. Facebook actually they don't have code. They said every user's picture data it might be pulled up anytime. Therefore, it's they only have a hot or warm. Okay, so why would they bother to do this classification? What do you think? So in terms of value and sensitivity, it will be the same, but still among those, oftentimes the companies does this classification, and what would be the purpose of doing this classification? If it's hot, what would you would do something differently, right? You can send. What's that?
Usage, data usage.
Data usage is more frequent.
Yeah.
Right, that's what it means. So then, so depending on the usage of the data, they classify differently with this temperature word. So the purpose of classification would be they would handle data differently, right?
Yeah.
So that's it. Yeah. So if it's hot data, that means that a lot of people are frequently accessing. That means that you better make the performance better. So not in terms of value or sensitivity, but performance better. That's what you want. You want to ensure the better performance for hot data. And maybe for cold data, it's something that's not frequently accessed. You want to still keep it, but performance probably doesn't matter. Therefore, so how can you do? Maybe you can put it in a lower end of the storage pyramid, storage place. Hot data, you want to put it in a higher level in the pyramid, right? So considering the cost and performance, they will make the decisions in terms of the how many replicas they have to put in. Of course, if you have an infinite amount of resource cost, then you can everything put it in a cache memory, everything in SSD or 3D Point, newer type of storage. But always in reality, you want to do more with less cost, right? Typically, it starts as a temporary storage, and then cache storage. It may be replicated and then backed up later, and even backup or archiving. There can be incremental and whole backup. So when you hear from UMKC, data center guest talk, the Mr. Frank McGrone will tell what kind of data management storage we do, or he does, and you will see incremental backup and whole backup too. What do you think? Which one is more expensive one between incremental and whole backup? Incremental backup, first of all, it means that you only do backup delta, any change. What do you do? Do you back up your data? I had a big incident once. I lost almost everything because I didn't do backup. I do reliability research and everything, and it's a shame in my life. Okay, so but typically what I do is that incremental backup, and then at the end of the year I do whole backup, right? So whole backup is a lot more expensive, taking more time, taking more storage. You probably do it in an external storage, things like that, right? The incremental backup, it's you do it on a more frequent, regular basis. Okay.
So I will keep this question open. What do you think? How often our university will do incremental backup and whole backup? And you'll find out the answer when he does a guest lecture. Okay. So for the guest lecture, I will have a questions given to you before his lecture. When you listen to his lecture, try to answer all those questions. Then also for data management perspective, you have to do provisioning. Whenever, suppose you have a terabyte storage and your usage is 900 megabyte, gigabyte, then you know that, it's time to increase your capacity, right? You do provisioning, and the thin provisioning is a relatively newer concept. Then because of that, the earlier one is called thick provisioning, traditional provisioning. Then also compression and deduplication may happen. So again, UMKC data center guest talk, you will hear about the deduplication, compression as well. And what kind of strategy, what product do they use, what's the level of deduplication? Those are the questions I want you to ask, or he might tell. So replication is for reliability as well as performance. Reliability can be for backup. It can be the in the same location, but also it can be in a disaster recovery, DR center place. Apparently, in the U.S., the Google, Amazon, or most of the public cloud providers you hear, they are known to be very, very reliable. We don't hear about the issues much, but they do. There are some issues every now and then, and you hear them from technical news. But other countries or other places, the DR could be more frequent issue. So there is a fire or the big electricity issue, and then system crashes, and they didn't have a DR, and then that means that their backup recovery will have an issue and can take a lot longer time. So I see some conference has the special panel on DR side. So data replication, we know that the solution pretty much well known, and that will be the solutions are pretty much well known, but still there are challenges too, and particularly the challenge is still open is concurrency. Okay. If you have a lot of copy in different places, making them coherent, concurrent can be an issue. This is not much of an issue for CDN type of thing. For Netflix, video is all the same content, right? So it's not, there is no concurrency issue. However, bank transaction or stock transaction, that kind of data, reliability is important, performance is important, concurrency is important, and that's still a big challenge. So don't think that storage, the problem is solved, nothing to study about. That's not the case. So here in this part of the lecture, this slide says like that, I am introducing a lot of words, right? It will be on the quiz, and I want you to be well aware of those. Then provisioning, all the comment, all of those, right? The storage services that we talked about. So in terms of security, right? security, one of the services is the confidentiality. And for confidentiality, we need to do encryption. Confidentiality is the gold service. The technique we do to provide the confidentiality is encryption. And then encryption can be done in a different levels. It can be done at the application level or database level, right? The Outlook email level, user entire email, or think about the Exchange server. They have database, so entire UMKC. It's not one database. They have multiple databases that can be a little bit smaller than one application level. So this high level encryption that can be possible, or close out one of the first slide over here. It can be also done done at the file system level, done by operating system. And then it can be host bus adapter or device level, the switch level, controller, the disk array controller level, and for that it can be for a file or per block for entire disk. Okay. So there are different levels of encryption that can be done. So this would be more of the multi-device, and this is individual device, disk array, entire array, or one disk. Encryption also or data protection. Another issue you have to consider is that when and where to do that. And it can be either, so again, I'm introducing the term, and it will be in the quizzes or exam questions too. In transit, while data being transmitted, that means that it is, while it is transferred through the network, how can you do that? Through a protocol. So once you hear, so we have a quiz on this today. So once you hear all these protocols, HTTPS, HTTP is the web protocol, right? S for security, right? SSL, TLS, FTP is a file transfer protocol. FTPS does the same thing with the encryption, security. So here the security means encryption. So for all these connection while data is being transferred, right? So these are providing data protection or encryption when data is transmitted. So this level of security is for, we call it in transit data protection, or in motion data protection, or in flight data protection. Yeah. Firewall and network access control is another one too. It can be done by user prompting or automatic encryption. Okay. So when it's done, where it's done, when data is being transmitted, that's in transit data protection. Another term we call in storage system for security services is called at rest data protection. What it means is that data protection, basically security in this case, the encryption in this case, it's done when data is not actively moving. What does that mean? In this disk storage system, it will be done. Okay? So by hard drive, flash drive, or in other devices, when data is sitting, not being transmitted, data can be encrypted, and that's at rest security or encryption. So it looks like we will, I'll give you access code, you'll do it later, okay? Then I want to talk about the provisioning. So before we head there, data is, there are so much redundancy in the data. We do it intentionally, but naturally, as we operate on data is just becoming redundant. Probably that's happening on your laptop as well. Or suppose in enterprise, this is original data, and suppose if you do rate 10 with 1, data doubles. And then you have to think about the extra capacity for growth. It will take maybe another amount. Snapshot for backup, you need the data. So whatever, not of the entire disk, but whatever data currently stored, you might take a snapshot, take the extra backup, right? And then maybe on a remote, DR, you have to have a copy of entire this thing. Then additional backup and multi-site, not just one, but multi-site archives. So if you think about just the original data, 1 terabyte, if you consider all these things, it's so much redundancy, one more tests and development copy, more than that, more than. So oftentimes it can grow, almost like 10 times. It can be even more. 1 mega, 10 mega, it's okay. 1 tera to 10 tera, it can be a lot. So just you continuously need more storage. It takes more energy to run those disks, data center space, the network bandwidth. It takes time to make a copy. It takes people to manage. The redundancy is good in general, but how much is good enough? I'm in this slide. I'm talking about data might get loose and may have too much redundancy. That's what I'm saying. But in some cases, you could argue data storage is getting cheaper, so it's not much of an issue. There can be some arguments like that too. But in this slide, I'm making the argument. Unnecessary redundancy is not a good thing. That's what I'm saying in this slide. Okay. Question, comment? No? So anything with you want to do some technique encryption. If you want to do it, it takes more time as well. So you don't want to do too much redundancy unnecessarily. So you have to have that kind of view, right? So what I'm heading to is that what are the techniques that reduce some unnecessary redundancies between RAID 5 and 6? RAID 5 and 6 might be better rather than RAID 1, potentially, because the animation is not good before now. So RAID 5 can survive a failure. RAID 6 can survive any 2 failures. RAID 1, it takes a lot more space. RAID 6 takes less space, right? Just n plus 2. RAID 1, in fact, if you have a 2 failure that on the same disk, you lose the data. But RAID 6, any 2 failure is okay. So
you may not be able to say that RAID 1 is always better. The RAID 6 could be even better, which takes a less space. So just don't think that more redundancy is always better. Another thing that in provisioning, as I mentioned from early on, so provisioning means that keeping future capacity for growth stored in terms of storage. So the previous slide you saw thick provisioning. You have additional space, all big ones, right? The thin provisioning. So previously you saw entire disk amount was provisioned. In this case, you could have actually a little less. That can have a better impact on any multi-site or remote site, the redundancy, right? So if you start with this small extra, then the overall you will see less unnecessary redundancies. That's the point. Here, keyword on thin provisioning is single free space buffer pool. So it's the storage pooling. That's what it means. In fact, that's what the virtualization does too, right? So here, that's our university too. Each user, I think in older times, used to have you can have a 400 gig for that's I'm not sure how much storage you have on the desktop or N drive, right? So rather than everybody has a big amount of disk, they will give us small per user quota, but once they go over, they use a pool of single free space. Then overall requirement of the storage, total requirement of storage will be less. Pooling is actually a technique you see a lot in many different places for saving resources. The DHCP IP address pooling, that's also pooling, right? The virtualization is definitely what it uses, the pooling. Containers, virtual machines, we use compute resource pooling, right? So in general, on average, the utilization is not that high. So rather than going for maximum the usage per user, let's start with small and have a single the space buffer pool. That's the end. So here is actually another picture. I don't want you to think that thin provisioning means that smaller space. The key idea is pooling, right? So here, on both sides, the thick provisioning, traditional provisioning, and thin provisioning, the capacity is the same, but the free space, if you look at this is a lot more compared to thick provisioning over here. But in this case, per user or per disk, it's a fixed allocated. So one user, suppose fill say this amount of disk space, cannot go over than that, right? In this picture, assuming somebody else is not, or some other disk is not fully utilized, it can be utilized for other users, right? So this is a lot more efficient. This is similar to statistical multiplexing, the even internet, rather than circuit switching versus packet switching, statistical multiplexing. on average, utilization is low. So let's not give an extra space per user or per disk. Okay. So that was about the thin provisioning. Thin provisioning, the concept is that, again, single the shared pool, right? Rather than per user pool. Okay, so I think this is a final part of this. The storage service is a deduplication. This a few years ago, one of my PhD students has done his PhD study on the storage deduplication. So the deduplication means that it actually sounds like the opposite of replication, right? So far we talked about replication is a way to go for reliability, but just before this, just having more unnecessary replication is not really good, right? There are also big technique, the pool of community, big community of researchers working on data deduplication. Despite, you might say, storage is getting cheaper and it's more abundant, still, if you want to do a lot of techniques, the having too much redundancy can can cause a lot of trouble in terms of management, applying techniques and so on. So deduplication can be actually important, and our university also does deduplication too. So the idea is that if there is a duplication, take it out. That's what it means, deduplication. If there are multiple copies of data, only keep one copy. That's what it means. Then, the saving will be better, right? So oftentimes you want to be able to access file from here and there. It can be still done without having a lot of duplicates. Just have a link, symbolic link, hard link, like in the Linux. You want to have just pointers to a single shared copy. And then here, there can be the level, the issue of the deduplication techniques is that what level of deduplication you want to do. Should it be per block level or file level or some other level? When I say some other level, that's where a lot of research ideas there. Block level, file level is some extreme fixed cases, right? So it's a little different from compression in a sense that I'm not really in good control of this clicker, so take a look at the wording over there. So compression means that you are not taking out any data, but to encode the data to reduce the total amount of storage that it takes. Deduplication actually is about to find, detect duplicates, and take it out. So you can use both complementarily, right? So deduplicated data can be also compressed. So it's complementary techniques. So deduplication, if you do it early on, the total amount will be reduced a lot. But actually, I think the picture is not exactly right. Deduplication also, techniques can be classified depending on where it happens, when it happens, and how it is done. Okay, so these are the. Oh, I'm sorry. I thought I have like 5 minutes and already. So let me just. That is completely stopped. Let me just. I think this is the last slide. Okay, let me finish this. So deduplication can be done at the endpoint or in network. It can be done
when data is being stored or already stored, and it can be done at the level of sub-file, block level, or file level. You can see something somewhere in between context level, the email thread. If you look at the email, there are a lot of threads if you just keep replying to the earlier email, right? So that's what actually my former PhD student had done as part of this work. So let me stop it here for today. And the access code, please. Let me. It's a data management. Without data hyphen MGMT. This is the access code. Okay, so I will let you take until the midnight today, and I will give you two options, two attempts. All right.